What volume of hydrogen, so let's put a question mark on the hydrogen there, is produced when 50 centimetre cubed of 0.25 mole per decimetre cube nitric acid? So let's put that on top of this one here, on top of the nitric acid. 50 centimetre cubed, and the concentration is 0.25 mole per decimetre cubed. So we've got a calculating quantities calculation here. 3 stages to calculating quantities always. Stage 1, moles. Stage 2, stoichiometry. And stage 3, moles again. Okay, so in this first stage here, we need to pick the correct moles equation. Now we've got all the information for nitric acid, and we've got volume of nitric acid and we've got concentration of nitric acid. So we need moles equals volume divided by 1,000 times concentration. So our volume is 50. We divide by 1,000 to put it in decimetre cubed, multiply it by concentration 0.25. Stick all that into a calculator. And we've got 50 divided by 1,000 times 0.25. 0.0125. So we've got that many moles, 0.0125 moles, and that's of nitric acid. So there's stage 1 done. Stoichiometry now. We're going to cross out magnesium there, we're going to cross out magnesium nitrate, because we're only interested in hydrogen, and we've got the moles of nitric acid. So we've got 2HNO3 from the equation. There's a 2 before the nitric acid there. There's no number before the hydrogen, so we can make that a 1, because there's always at least 1 present. We never write the number 1, because there's always at least 1. We use numbers bigger than 1 when they're appropriate. So 2 moles of nitric acid makes 1 mole of hydrogen. That's what the equation tells us. So how do we get from 2 to 1? Answer, we have to divide by 2. We halve it. Half a mole of hydrogen is made from a mole of nitric acid. Now we don't start with 2 moles of nitric acid. We worked out we start with 0.125 moles. 0.0125 moles, I should say. So whatever we had to do there, we have to do here. So we're going to divide that by 2, and that's going to tell us we have 6.25 times 10 to the minus 3 moles. 6.25 times 10 to the minus 3 moles of hydrogen. Okay, stage 3. Stage 3. We've now got to use the correct moles equation. What's it asking for? It's asking for the volume of hydrogen. We're told 1 mole of any gas at room temperature and pressure occupies a volume of 24 decimetre cubed. So we need the moles equation for gases here. That is moles equals volume divided by 24. Then we need to rearrange that because the question asks us for what volume. So volume equals moles times 24. We've got 6.25 times 10 to the minus 3 moles times 24. And that should give us our final answer. 0.15 decimetre cubed equals 0.15 decimetre cubed. All these questions on aylsham high chemistry.com.